This
question.
conference will now be recorded.
Michał or myself will be taking questions from the chat box and passing them on to speakers. There is going to be a short Q&A session after each presentation, and for any late questions, we will have a wrap-up session at the end of the webinar today. Just to remind, the topic of today's webinar is environmental impact of the wind farm. And before we will start with the first presentation, I will ask Michał to introduce himself and introduce then the first speaker. So Michał, over to you.
Thank you, Janusz. I hope you hear me well. So my name is Michael Sobczyk and I represent Scottish Development International, trade agency of the Scottish Government, and we are working jointly with the AT to bring you those webinars. This is already 6 or 7 technical webinar we're organizing this year, which will have 2 or 3 upcoming in November and December. We'll be sending this information shortly to you. And as Janusz mentioned, please ask questions during the webinar. After the webinar, we also will be happy to connect you with today's speakers. And without any further overdue, I would like to introduce our first speaker, Dr. Mark Powell Buckingham from Sea Engineering. Mark, over to you.
Thank you very much. Good morning, all, and thank you for the opportunity to speak. I am going to cover the services to offshore wind and underwater acoustics. As I said, my name's Dr. Mark Paul Buckingham, and I'm Managing Director at Sea Engineering. I will be taking questions at the end, so if anyone does have any, please feel free to ask.
We can't hear you. You are probably on mute.
Oh, did you hear any of that?
Now we can hear you.
Okay, my apologies. I don't know how I went back to mute. My name's Dr. Mark Paul Buckingham, and I'm Managing Director of Sea Engineering. Apologies for that technical issue. Effectively, we merge the virtual and real worlds. We take real world data and combine it with virtual prototypes or virtual systems in order to either accelerate product development and reduce risk, or actually remove barriers to technical deployment. So within this space, within the offshore wind and underwater acoustics, we remove some of the technical barriers during the EIA process, which I'll come on to speak more about. So our origins were actually in noise and vibration. We span out of Edinburgh University, where we did a lot of complex dynamic engineering. This has allowed us to improve our skills and capabilities to allow a lot of offshore deployment to be taken forward and removing the environmental barriers. So, sorry, I have a dog in the background. Sea Engineering, the name Xi comes from a damping ratio. We're full of technical. We're a technical team, and we decided to name ourselves after a technical variable we use commonly in our work. We've worked with a majority of large utility companies and the majority of wind turbine manufacturers themselves. As you'll see from this list, I'm sure you'll recognize some of them, all helping in assisting either their turbine technology or allowing them to deploy and removing barriers to deployment. As I said, we merge the virtual and real world. So I'm going to give you a couple of examples of some of our digital twins and why they were produced, and then some projects specific to the offshore wind sector. So we worked with GE Renewables over in Germany, and they wanted to improve their wind turbine performance, specifically with relation to noise and the acoustic emissions. So what we did with GE was develop an acoustic model a full holistic system. We measured in the real world, combined the two, and then we were able to optimize their system to reduce the acoustic emissions of the devices, allowing for increased deployment of the system. Another example of a project we've worked with, this is Andritz Hydro Hammerfest. They have produced 3 versions of tidal turbines. The one on screen is the HS1000. So we assisted the manufacturer in optimizing their system for both being maintenance free. They wanted a 5-year maintenance free period. So during the design phase, we were integral in terms of reducing the fatigue and the likely maintenance requirements. At the same time, we were able to produce the acoustic emissions of the devices, which then allowed them to deploy these devices, understanding what the signature would be and how it would affect marine life. And the last of the digital twin examples, this is clearly not offshore wind, but we work with Ocado Technologies, who are developing a robotics-based logistics system. And this is a huge digital twin, some sort of 300 meters by 300 meters, in order to optimize the device for deployment across the globe. So moving to the specific area we're concerned with today, in terms of EIAs, I'm sure you're all aware that the EIA directive, which everybody works to within this field, certainly Scotland has its own take on this. Each of the different regions will do. And really, you've got to cover what all the impacts are going to be of a deployment of offshore wind. And the project's got likely 26 significant environmental effects, which needs to be considered. A few of these I will now cover in this presentation. As a summary for what's required in an EIA report, obviously it needs to cover a number of factors, you know, what the likely impact is on the population and human health. Biodiversity is one of the key concerns and the key areas we assist with in terms of ensuring that the likely output or the predicted output will not cause an issue to different habitats. Then you're covering basically land, soil, water, air and climate. And then obviously any material assets or cultural heritage must be considered through this process. But I'm sure there's plenty of people going to cover this in greater detail later on. So in terms of ecological considerations, you need to look at the impact of noise on marine mammals. You've got to look at the noise detection by these mammals. So can they hear it? Or what level would they hear it as the different receptors? And is there likely to be a behavioral response to this? Certainly from deployments we've done, we need to ensure that the marine species are aware of what's going on, but obviously not to a level at which you're likely to move a population because it's been too noisy. You've got to look at the hearing sensitivity of the marine mammals. And what we do is look at the species audiograms and then assess what the likely behavioral responses are. So we have a number of ecological partners we work with as well, because obviously we do a lot of the noise propagation modeling, which I'm about to cover. I believe we're going to have a presentation from APEM, who we've worked with on numerous projects, along with the other companies here on the slides. So in terms of marine renewables, you need to cover a number of steps, looking at initial analysis or pre-scoping, which we can help with our partners provide support for. Looking for support for the marine and European protected species, which are key to consider, and we look at the audiograms of all of these when we're looking at predicting the noise levels. The EIA and support for marine mammals, and covering specific chapters, and then looking at both the ambient underwater noise and the likely effects during construction, operation, and decommissioning. And we do that through some extensive, accurate modeling. So to give you an example of some of the underwater projects now, I'm going to run through before I finish up, so I'm happy to take noises. But we cover areas such as piling noise, so we're able to predict the piling noise and what the likely effects are. The operational noise of wind turbines, the foundation effects of offshore wind turbines, tidal turbine and operational noise. Obviously, we're focused on offshore wind here. But then you've got to look at the facilities onshore as well. So whether or not facilities onshore are going to affect marine species. You've then got cable laying and the noise that might have an issue there. And within the UK, we have to look at what the Ministry of Defence or the MOD, what their requirements are. So you can see on screen here, this is a picture of the HS1000 being deployed. And the sound production of the device, which we can simulate and then put into combine with the bathymetry in order to show how the effects would be, whether it were deployed as a single device or multiple devices. We've done extensive work with the Scottish Government and Marine Scotland. One of our publications, which is available on the Scottish Government's website, if you're interested, there's a link in this presentation, so hopefully it will be distributed at the end. But what we looked at here was what the different effects for operational noise would be for different types of foundation, offshore wind turbine foundation. So we looked at pile foundations, we looked at gravity-based systems, and then we also looked at jacket systems and how each of these would impact the different species. So as I said, this report's available. I've got some of the highlights here from it. So looking at the sound pressure levels at different frequencies as produced by a pile foundation we have here on the screen. So obviously these are device specific, but we're quite happy to produce these for any scale of turbine so that the consenting authorities understand what the operational noise from these turbines is likely to be, and then the effects that they have on the different species. Another underwater project, this one we worked with SAMS and SRSL. So again, this is a tidal devices, but we were looking at how different devices underwater would affect the different species, again through producing a propagation modeling capability, and then we put this into the bathymetry, and then you're able to see what the likely effects are. I think I've covered the Andritz Hydro Hammerfest, but here was a specific site in terms of the noise propagation. To the left of the screen, you can see the effects of multiple devices deployed simultaneously by the islands of Islay and Jura over in Scotland. Obviously, when it comes to cable laying, there is, once again, it's another area you have to assess during your EIA. And we've worked with numerous companies now. This one was specifically for SSE, against with SAMS and SRSL, where we were looking what the impacts of the cable laying and activities in getting the cable to the Shetland connection up in the north of Scotland. So looking at the different activities, we combine it with the bathymetry, and again we can propagate the noise, and then we can also see what the effects are on the specific marine species. Another underwater tidal device, this is the West Island of Islay. What you can see is a sound pressure level created by different numbers of devices deployed on the seabed, combined with bathymetry, and once again we'll then look at how that impacts on the specific species, looking at the different mammals that require dolphins, whales, and also migratory fish, such as the salmon, sea trout, and the eels. You must take into account, obviously, any impacts you have on land as well. So we commonly do a lot of work around what the likely impacts are on piling noise and activities within harbours. This project was a specific harbour extension down in the northeast of England, and it was very close to sensitive populations of different fish species and marine mammals. So once again, we look at what the activities are going to be, and we can produce the underwater noise impact from the piling and the onshore activities to ensure that planning authorities are allow for these to go forward. So you've got piling in the estuary, you've got vessel noise as well, and trudging running through. Oh, sorry, I've rattled through that presentation, so I'm slightly ahead of time. My apologies. Hopefully I've covered all those points, but would happily take any questions on predicting offshore noise and acoustics in order to allow for your deployment of offshore wind.
Thank you, Mark Paul, for this very insightful presentation. So if any one of you have any question, please put the question in the chat zone. If not, we'll always be happy to schedule a follow-up call with Sea Engineering and talk about the details. So please reach out to me if you'd like to talk after the webinar. And now I think we can move to the next speaker, but still, if you have any questions, please put it in the chat zone. I know, Mark Paul, that you need to leave early, but if there be any questions, we'll send that and follow up on this. So now I'd like to introduce to you our second speaker, Andrew from Ace Aquatic. Andrew, over to you.
Okay. Just make sure that my screen is shared okay. Okay. Can you okay? Can you see that? Okay.
Yes.
Okay. Perfect. So yeah, my name is Andrew Gillespie. I'm the Fonagard Business Development Lead at Ace Aquatic, who are a Dundee-based aquaculture and marine equipment company. We have built a reputation on developing innovative products that address the ethical issues in those two sectors, by encouraging and also accelerating the adoption of sustainable marine practices. In the last 18 months, despite the coronavirus pandemic, we've opened a new headquarters in Dundee at the waterfront, in addition to opening branches in Norway, Australia, and Chile, and also expanding our Canada office. We pushed ahead with our 2020 recruitment plans. We've gone from a team of 5 last year to 35 employees worldwide. And our current investors, Aquaspark in the Netherlands and Chroma Ventures here in Dundee, they are continuing to back our numerous humane and environmentally responsible research and development projects. So a bit of background, in 2018, a strategic partnership between ourselves and Van Oord, dredging and marine contractors based mainly in the Netherlands, that brought together sort of expertise of 2 innovative leaders in their respective fields. They, Van Oord, wished to team up with a partner that had considerable experience in developing, renting, and also the servicing of acoustic deterrent devices. Because ultimately that type of, sort of specialised technical equipment wasn't within their scope, it hadn't been part of their key knowledge or services provided by Van Oord. And you might be thinking, what is Fonagard? Well, it's a set of species-specific modules that have been designed to remove marine fauna temporarily from active construction zones, using safe levels of underwater acoustics. Sorry, went too far. So again, just to explain the story a little bit, back in the 1990s, an inventor called John Ace Hopkins, where the Ace from Ace Aquatic is derived, he was working for technology company Franti Thomson on seal scaling devices, and Franti took the decision to divest some of their non-core business. John acquired the relevant licenses to continue working on them. He set up Ace Aquatic and was providing some truly groundbreaking, innovative technologies for an aquaculture industry in Scotland that was booming. So yeah, we've been firmly established in aquaculture for the last, you can see that since 90s, 2000s. And we started developing projects for offshore wind in the last 10 years, notably our marine mammal mitigation device. And Van Oord had been using prototypes of the FaunaGuard modules on different projects around the world as a solution for meeting those environmental regulations in marine construction activities. And we learned that Van Oord were looking to commercialise the FaunaGuard, and we thought there was excellent compatibility with our existing product range, and we could offer our knowledge and expertise. So we opened conversations with them about developing a unified system. So within the partnership, we are responsible for dealing with client contact, shipping, servicing equipment, as I said, and Van Oord have been largely responsible for the networking, communication, research, market intelligence, and promotion online events. The FaunaGuard systems combine academically validated sound patterns devised by the Van Oord partners and noted experts Ron Kasteling and Hans Slabakon in the Netherlands, with award-winning transducer devices that have been designed by us, and also Neptune sonar in the northeast of England. And effectively, by introducing sounds at specific frequencies, we can ensure that any impact of loud sound-producing activity on marine life that is minimised to the client's satisfaction. So we have customers all around the world specifically requesting FaunaGuard us to supply it for offshore wind projects, typically at the installation and commission stage, but in addition to other marine projects such as unexploded ordnance, clearance from power plants and sea turbines, spawning protection, oil spills. And you can see some of our who our devices have been recommended by, who we've worked with in the past, a little bit of our relevant experience. You can see in Hollandse Kust Zuid recently, in order to keep underwater noise level as low as possible, a bubble curtain was implemented there, which shields the environment from loud sounds. And the environmental impact assessment for that project also required measures for ensuring the protection of porpoises during the jacket installation, in terms of avoiding any risk of temporary shift in the auditory threshold. So through combined use of the bubble curtain and our FaunaGuard porpoise module, the impact of underwater noise was minimised, and porpoises were temporarily moved to a safe exclusion zone for the duration of the project. So as noted, we can protect multiple species of marine fauna which have the potential to be adversely affected by the impact of anthropogenic sounds that originate from marine activities such as dredging, piling, rock installation, blasting, industrial activities, drilling, shipping, or even military activities, types of sonar, geophysical exploration, and seismic surveys. Any instance of a protected marine species being spotted in a designated exclusion zone, it can cause unexpected, costly shutdowns, I suppose, and delays until that site is cleared. So FaunaGuard can help avoid cease on operations and in turn any potential reputational damage. You can see on the left there's an artist's impression of a fish module being deployed from I think it's the Aeolus vessel, Van Oord's Aeolus vessel. On the right, that's our FaunaGuard porpoise module, which has been deployed from the side of a vessel. It's a nylon pod, goes into the water, and yeah, it's switched on prior to works commencing. Traditional mitigating measures, I suppose, involve, as I said, pausing activities or cease once animals have been observed, either visually or passive acoustically, in the vicinity of the works. And physical measures can be deployed as well, such as turtle deflectors and active relocation. And those methods, although successfully used in practice, they do have limitations. Visual observations are less effective when marine fauna are not at the surface of the water, or when visibility is generally quite low, such as during bad weather or at night. And methods that rely on physical contact, may cause stress to marine fauna and are often not allowed. So, yeah, as noted, Fauna Guard proactively repels marine fauna from those construction sites, specialised safe levels of acoustics, and avoiding work delays and physical stress. So, we've got 4 jointly developed Fauna Guard modules. Those are commercially available to marine contractors and other interested parties. We have our fish and turtle module on the left, in the middle our seal module, and the porpoise module on the right, which was the first of the 4 on the market when ourselves and Vanguard had formed that strategic partnership towards the end of 2018. And the porpoise module is probably our most popular hire, given the sort of prevalence of harbour porpoises, it's been approved for use by the Federal Maritime and Hydrographic Agency, also known as the BSH in Germany, for installation and deployment in the exclusive economic zone of German waters. Ultimately, the philosophy of Fauna Guard is to make optimal use of hearing capabilities of various target species and focus sounds using modern acoustic techniques. It can be deployed sort of 15 to 30 minutes before the start of loud sound-producing activity, which can be dangerous. And there is a soft start built into it, so it allows animals time to move away prior to noise becoming potentially harmful. And those sounds they're produced. There's a computer inside the control box, produce sounds completely at random. And those sounds, there's different tones that can be activated. They remain novel, so that animals are less likely to habituate to our signals, our tone patterns. And although we use higher yet still acceptable volumes of sound to protect caged fish on the sea farms in the aquaculture sector, our research has demonstrated that lower volumes have a greater effect when there's no food source for marine mammals to stay in the area. So, in order to guarantee performance, we continue to collaborate with several marine research institutes and universities worldwide. Independent experts in the field of marine biology and underwater acoustics are involved to determine suitable sounds and to study their effectiveness, first under laboratory conditions and then followed by tests, basin studies, and with animals then in their natural environment, looking at field study. So yeah, and each module, each of our 4 modules, and any sort of future developments, they would have to follow that complete path from literature study and theoretical sound development. Then those basin tests to determine the behavioural response levels to the sound patterns, and then field tests to determine the success rate. So each module, as I said, comes equipped with a soft start, which is a gradual ramp up of volume. It's purpose built for the target species, but it is possible, as opposed to combine several modules into one device, such as our very or low frequency fish turtle module and our high frequency porpoise dolphin module. We also have available our original mid-frequency marine mammal mitigation device, which is for overlapping cetacean and porpoise exclusion. That device uses sort of short, sharp tonal bursts, the original ACE aquatic startle response, at higher volumes as opposed to low volume, long duration sounds as emitted by the phonograph devices. If you're really interested, the pods are fully submersible to about 100 meters. The acoustic output of the mid-frequency device peaks at about 195 decibels. So it's just as I say, it's 8 or 9 different 2.5 second bursts at 8 to 20 kilohertz, and it has an observed efficacy of I think it's 50 meters to about 2 kilometers. It'd be heard quite a way away. So the ability to deter animals safely from construction works, it's definitely going to become much more important due to ever increasing rules and regulations surrounding sustainability. In certain regions, it's now mandatory to use such devices in order to execute an offshore wind project. And strict regulations are obviously being imposed in marine environments by governments, but by clients themselves, by funding agencies. And one example of international legislation would be the EU Marine Framework Directive, which increasingly aims to keep sound levels in sensitive environments within acceptable levels. So in short, a combination of the ACE aquatic hardware, the Vanguard philosophy, plus a shared environmentally responsible ethos means that the partnership has been hugely beneficial for ourselves, the two companies, not only for us, but for the environment as a whole. And in collaboration with Vanguard, we plan to further develop each of our PhonoGuard modules. That ultimately requires hardware developments and also continuous research into sounds and to hearing across various marine fauna species. And yeah, if at any point, obviously I believe the slides will be shared and the recording will be available, but if you want to take a note of my contact details and you're interested in ACE aquatic or PhonoGuard, then please feel free to reach out at some point. Give me an email, drop me a message, and I'm happy to.
Thank you, Andrew. Thank you, Andrew. So yes, if you have any question to Andrew, is the right moment to put your question in the chat box. And if you still need more time, please reach out to Andrew directly or through us. We'll be happy to talk to you individually and see whether we can work together. I still don't see any questions. Please don't be shy. And it's a good opportunity to ask any questions from the company that already have experience in offshore wind in UK and in other markets. So I hope we will get some questions today. And now I'd like to move to our third speaker, Rafał Libera from Acteon Group. So Rafał, if you are with us, it's over to you.
Hello, thanks, Michał. Well, welcome, good morning from sunny London. Let me share my screen, so bear with me a second. Right, excellent. I hope everyone can see that now. So my name is Rafał Libera, and I represent Acteon Group. And today, what I want to talk to you about is the solutions, especially in terms of piling installation for the next generation of wind turbines. So you've heard about the piling noise issue from the previous speakers. So I want to expand on that topic and also tell you a bit about how Acteon, what kind of solutions Acteon offers to solve the incoming challenges. So just a brief overview of Acteon. We are a marine energy and infrastructure services provider, and we have industry-leading products and services for the renewables sector, which is obviously the topic of the conversation here, as well as the nearshore construction, oil and gas. And what we pride ourselves on is the fact that we can help our clients across all phases of the life cycle of each project. So what does it mean for the renewable sector? Well, we do have proven and innovative solutions across all stages of the life cycle in design, engineering, installations, as well as operations. And those solutions help our clients drive down the cost of wind farm installation, for example. So we help customers, and have been for many years, installing larger turbines in deeper waters at the same time as well, minimizing the environmental impact during the installation process. So one last slide about how Actien is organized. We have 8 segments across the group, starting with geoservices, where under the lead brand of UTech, we perform geophysical and geotechnical service, all the way to offshore engineering under 2H, where we provide pre-feed and feed design and engineering solutions, to asset integrity and monitoring. And on the other side, moving to the topic of the conversation, which is foundations and cables under our lead brand, MENC. So, because a picture always says more than many words, what does Actien Foundations and Cables segment do? Well, we worked on a whole spectrum of foundations, starting from the left, the monopiles to jacket installations, as well as now very still developing topic, but a very with great potential, floating wind foundations. And I'm not talking here about fixed foundations, but rather the mooring installation. Right. So moving on to what does MENC offer and has been offering. Well, we've been on the market for 150 years now, and our hydraulic hammers are for rental and sale. We offer them for rental and sale all around the world, and our units are operated globally by our in-house offshore technicians. We have a hammer portfolio throughout the spectrum, starting with 100 kilojoule all the way to the newest, and this is actually the world's most powerful hammer, of 4,400 kilojoule. And in terms of top diameter of the monopile, we can service up to 8 meters at the moment. And that is the capability of our hammer portfolio. We also, although that might be not relevant for fixed bottom offshore wind farms, we have deepwater power packs and hold the world record again of 2,100 meters for the greatest water depth where a pile has been driven. For the offshore renewable sector, we offer the MHU 3500 family, which stretches from 2,400 kilojoule all the way to the world's most powerful hammer, which I just mentioned, the MHU 4400 with 4,400 kilojoule power. So that's about Actien and MENC. Now, what do we think is the challenge that we all facing across the offshore wind sector in the coming years? Well, if you look at the development of the offshore wind sector over the last decade and compare it to what's going to happen in the next decade, there's exponential growth in terms of the number of offshore projects that will need installation and will need solutions and supply chain to service those offshore wind farms. The per annum installation of offshore wind farms will go from 3.7 gigawatt to 27 gigawatt per annum, which is 7-fold increase. And not only that, also the output of the turbines, of the new generation of offshore turbines, will increase up to 15 megawatt. Well, while the monopile remains the most cost-efficient foundation, the fact that the turbine size will grow to such an extent has certain implications for piling. So what is exactly the challenge? Well, the new generation of turbines being installed from 2023 onwards, and definitely for the offshore already, when we look at the predictions, or rather the plans of the offshore wind farm developers in the Polish Baltic, that's this kind of size of offshore wind farm turbines that will be applied to those projects. So the implication is that with the greater size of the turbine, the underwater noise will increase. And as we've heard for the previous speakers, that is something that is very on the top of the mind of regulators as well as developers, to minimize the environmental impact of piling installation. That is why, in a way, anticipating this development, MENC, together with Novikos and the University of Hamburg, jointly conducted a research project from 2018 to 2020 to develop adequate strategies to respond to this projected increase in piling noise. And what I can tell is that the results of that research are promising and will be implemented into a new Homer design for larger monopiles that will be used in the forthcoming project. So at Action, we always want to respond to industry demand and want to develop a world-class noise mitigation technology. So to give you a bit more scientific flavor to what the issue is, I'm just presenting here the graphic used by Dr. Michael Bellman of ETAP. What it means is that with the measured result that Dr. Bellman has conducted, the noise emission will increase with the increase of the monopile diameter. And with all the existing underwater noise mitigation measures that are currently available, it will be nearly impossible to stay sufficiently underneath the requested limitation of 160 decibel, which is the applicable standard in Germany as well as in Taiwan. And obviously, we've already spoken about the EU regulations in that respect. That's why we need to develop new technologies to make sure that this noise is being mitigated adequately. So, looking at the graphic that Fabian Wilke presented some time ago, a reduction from 180 decibels to 160 decibels means a reduction of a factor of 10. So corresponds to 90% absorption of 90% of the energy in the water. And in order to achieve that reduction, several underwater noise mitigation measures need to be in place. At the moment, the practice is using secondary noise mitigation systems like bubble curtains or near-field system like ADBM, which is limiting the existing noise levels underwater. In other words, absorbing the energy once it is underwater or in the water. Well, what we want to do is to reduce the energy before it is given into the monopile and then from the monopile into the water. So how do we do that? Well, we identified, our R&D department, our very capable engineers did that, identified that the force character of the hammer is a very promising parameter of optimization. And we developed the MENC noise reduction unit, which can be assembled onto the hammer. And it will increase the impulse length of one blow of the hammer. So changing the force character and introducing the force over a longer period of time will allow us to get rid of the peak force in the structure. And with this reduction, we achieve using simulated models, a significant reduction of between 7 to 9 decibels. So this is a very, very promising development, one that will really allow piling installation for the larger monopiles, for larger turbines, to really, really stay within the bounds of the current regulations. So to sum up the MENC portfolio and the offering, well, we offer state-of-the-art piling solutions, and parameters of our hammers make it the optimal solution for both monopile and jacket foundation installation. And as I mentioned, the proprietary MENC underwater noise reduction unit, MRU, has been developed to address the ever-increasing demand to meet regulatory limits on underwater noise. Underwater noise pollution is an essential challenge today, and MENC and Action Group is committed to contribute to the sustainable development of the offshore wind sector. And the MENC noise reduction unit can be added as a component and integrated into any MENC monopile or jacket foundation. I apologize, I think something happened to my sharing of the screen. Let me try that again. Okay, excellent. So moving on, but Action, we firmly believe that the whole supply chain needs to work together to solve the challenges that come with the growth of the offshore turbines, the offshore monopiles, and the coal-related increase in noise. So how can we support the incoming projects in Poland? Well, under protection of an NDA, we can provide and are prepared to share detailed information about our hydraulic unit in order to allow independent third parties who can model or simulate underwater noise with detailed design data about our hammer. This will enable developers and designers an independent view on the optimization and the expected underwater noise level. In addition, we also support all developers with drivability studies. So that's something that we are more than happy to offer as well. So onto our track record. Well, we, as Action and MENC, have worked all over the world on offshore wind foundation installation, particularly in Europe, in the North Sea, as well as in the Baltic Sea. And two projects I'd like to mention here briefly is the Wikinger offshore wind farm in the German Baltic, where we took part in the installation of the jackets with MENC, with UTech providing support, as well as designing the pre-piling template for the jackets, as well as Krieger's Flag in the Danish Baltic Sea, where we pride ourselves on having installed 72 monopiles in record time. At the moment, we are working on Taiwanese offshore wind farm projects, as well as in Europe's biggest currently biggest offshore wind farm, Hollandes Kust Zuid, that is being developed by Vattenfall. So to sum up, what is Action about? Well, we always take a proactive approach and want to innovate for our customers and our clients to ensure that we can support the developers and other clients in successfully delivering renewable projects on time and within budget. So thank you for your attention. If you have any questions, please contact me at the email address or indeed in the chat box now. Thank you very much.
Thank you, Rafał, for this really good presentation. I still don't see any questions, but you can reach out to Rafał after the event. We'll share the contact details to Rafał. And as far as I know, Rafał will be in Wrocław next week at the DISA conference. So those who are attending this energy conference in Wrocław, you can meet for coffee with Rafał, but also with our embassy team. So let us know. We'll be happy to talk to you. And now I'd like to go to our next speaker, and Gillian from APEM. Over to you. The floor is yours.
Morning. Let me just share my screen. Great. Well, good morning, everyone. Thank you for the opportunity to speak here. I was just looking to cover today to share my knowledge and experience of working in offshore wind over the last kind of 15 years, primarily as an offshore wind developer and more recently in an environmental consultancy. So what we're looking to talk about today is really about the importance of the basics of ecological design, importance of understanding what you're looking to study and to how we're going to do that, and actually why we're doing that. In my experience, working across wind farms across the globe, a lot of the environmental factors are very similar. Whilst it's very important to look at the local angle in terms of understanding what's on your site, there are a lot of synergies in terms of how we actually approach the data and make the most out of that as well. It's also very challenging as well to apply the ecological principles in standard design into the offshore environment, where there is a lack of that data, the baseline information, and then the logistics of actually sampling in that environment can be particularly challenging, not to mention the timescales. So we're going to look today at a couple of areas, just really to introduce you to APEM. So APEM is an environmental consultancy. We work throughout Europe and also internationally. We provide scientific services across both the environment and the water cycle. We work with a range of clients, including regulators and public bodies, private developers and academia. We've set out best practice standards for our aquatic laboratories, also marine wildlife surveys and drought planning, and we really are at the forefront of leadership in ecological surveys and environmental topics. In terms of the agenda that I'm going to cover, it's really about looking at, from a scientific perspective, the aim of what we're looking at is about understanding the importance of the quality and the value of data that we can collect. It's about the hypothesis we set, I guess, for this presentation, really about thinking about what we can learn from the past. How we do that is actually about sharing our ideas. We've seen some excellent presentations already about technical advantages and engineering solutions that have been developed. And also, actually measuring the success of that as well. So critically looking at the monitoring, the importance of monitoring programmes and how to get the most out of them. And finally, we'll look to review the learning and the recommendations through case studies. So one of the key areas that I've really come to recognise is that collaboration is key. So understanding from the outset about actually what you're looking to achieve and the benefits of actually collaborating on understanding what you're trying to achieve is really critical and can save you a lot of time in the long term. So recognising the different roles of various stakeholders, whether that be regulators, whether it would be the actual developers or the nature advisors in terms of whichever country you're working in. There are absolute benefits in terms of agreeing those methodologies up front and looking to address any differences that they may have in terms of scientific opinion. If you do that from the outset and you understand and set aside what you can actually focus on and what you can realistically deliver, it ultimately means that you should be more acceptance once you get to the end of that programme. One of the key things actually is about looking at standardisation, so having again collaboration or actually published standards either globally or within regions or within countries can be really important, and also that can help you improve the power of data. So one of the examples that we have from this is specifically with regards to noise effects from offshore piling. There was a study undertaken by the BWO known as GISHA, so there was two parts to that study. Part one was looking at the earlier years, part two in terms of 2014 to 2016, basically collaborating data sets from marine porpoise monitoring data from passive monitors using porpoise detectors, seapods, and also combined with digital aerial survey data. To basically collate those data sets and look at the wider impacts in terms of what that effective noise is happening to the population in the area, and that was within the German Bight. So really useful study, really nice to see lots of developers collaborating with industry representatives as well to be able to present that information. Another similar study undertaken in the UK with collaboration of developers and also scientific experts is the DPONS project, which was led by Aarhus University. Essentially, it was a process-based model that was created to look at assessing the population effects of disturbances on mammals and specifically harbour porpoise in the North Sea. And that tool has been created over a number of years, gathering a lot of information in terms of the effects on individual harbour porpoise and looking to model that. And that tool is publicly available. So really, again, a really fine example of the importance of collaboration. It's also really important to actually differentiate in your studies about whether it is a research goal or whether it is specifically a monitoring in terms of monitoring the impact of offshore wind. And those can be confused, and therefore in terms of acceptability of the outcomes that can cause problems. But they can also be very complementary. So a couple of the projects listed on here, so the ORGIP project and the OSMIRF project, Essentially, they were looking, and also the Scotmire project actually, they look to identify the evidence gaps and get collaboration and agreement on what those evidence gaps are to allow developers and other research bodies to then take responsibility for finding ways of meeting those gaps. So really important to see that. The other point to note in terms of collaboration is actually about the ability to adapt to change. So also accepting innovation. You know, as we've seen, it's been challenging over the last 18 months in terms of responses to COVID situations and cancellation of ship-based surveys, etc., which has led to looking at alternative means and actually ease of delivery for alternative means such as aerial surveys. Oh, sorry. There we go. So the other aspect to consider in terms of the design is really about the value of the study itself. And as I mentioned, it's important to understand the objective of the study and whether you're looking at a monitoring study versus baseline characterisation. And by really looking at that, you can make sure that you do generate, a statistically robust sample size. You can use power analysis to make sure that that is fit for purpose. You can look specifically at the receptor itself. Think about, the actual appropriate timing, frequency, and duration. And whether that is needed more contextually for the site characterisation side of things, or if it's really focusing in on a particular impact. But the importance of understanding that wider environmental content, particularly in the offshore environment, is really critical to make sure that it is fit for purpose. So traditionally, if that's about environmental impact assessment, then actually determining some of the other external factors that may affect that other than just the development itself. So the variables in terms of the environment are really important to capture and to document. As mentioned previously, the standardisation is also very important, but there should be a recognition within that whilst that can drive consistency in terms of being able to collaborate data sets, there's also a need for evolution in that as well. So it should be knowledge fed, and there needs to be that feedback loop to enable improvements within that. So we can look to see collation of data. It can be at the national level, European level, and also we can see that there are contributions towards wider data sets, such as examples and data programmes that are presented here. So, across the European level, any of the data that we're gathering in terms of the offshore wind farms themselves during that construction or operation can be used and very successfully contribute towards wider data sets. The Joint Citation Data Protocol in the UK, for example, it's run by JNCC, that enables us to collate all our data that we're collecting, typically from digital aerial surveys, on marine mammals and put that into a wider data set, which then can be shared and used for many purposes. JNCC also hosts the UK Noise Registry, which can then contribute towards and is used towards measuring good environmental status for the Marine Strategy Framework Directive as well. The other point to showcase here is really in the UK is really learning about, actually ensuring that data sharing requirements are actually mandatory. So those are stated within the lease from the Crown Estate. So that ensures that anybody that's building an offshore wind farm has to provide that data, and that's made publicly available in the Marine Data Exchange that's listed on there. So just to give a specific example of the benefits of actually having guidance there, like just thinking a bit more widely, thinking about benthic environments as well, specifically looking at development of a guidance from Natural Resources Wales. This was looking at the benthic habitats and setting out overarching principles with regards to sampling for benthic habitats for developments, marine developments, so offshore winds and cables, but also wider. It was really important in this regard that it set out those key principles, but was not overly prescriptive as well. Because there is a recognition that there does need to be tailoring of those to site-specific nature and scale of the development or the activity itself, but also recognising that this guidance can be used not only for environmental impact assessment for general kind of marine licence applications or defining if activities might be exempt from that regulation, also the Water Framework Directive, and as mentioned before, the MSFD as well. So it's really important, again, in that document, it distinguishes between those sampling strategies for wide baseline characterisation studies or focused monitoring studies where you really do need that power analysis to ensure that you're going to deliver what you want to ultimately get to. The other aspect just to touch on here is really about ornithology, and primarily for APEM we are delivery of world-class digital aerial surveys. That evolution of the survey design, so traditionally in the offshore environment, that has been characterisation studies have been carried out by boat-based surveys that then moved to visual aerial surveys, and now we're seeing the top of the game is really this digital aerial surveys. So there are a number of operational benefits in doing that, as well as biological and statistical benefits. It does allow more confidence in terms of the data sets as well, so they are fully auditable. There's a permanent record there. And it reduces the kind of human error in terms of actually capturing that data in the first place. And the important side of it is really about actually learning about the importance of data and how that influences decision making, to look to actually improve the quality and the data of it as well. So initially when that started out, it was 3 centimetres ground sampling distance. That's improved now, and APEM offer routinely 1.5 centimetres ground sampling distance, and that enables us to get better species identification and to be able to see actually the images are much clearer, and again improve the quality of the data. We also look at the power analysis aspect of things as well, so ensuring again that we've got the right sample size, whether that be for a characterisation study or whether it be for the actual monitoring itself. One of the key things that we've seen in terms of managing uncertainty is that, again, through impact assessment, the importance of flight heights of birds that are generated from our surveys is really critical, and that can have an important effect in terms of defining air draft heights for wind turbines, which also leads into the design and the engineering aspects. So within APEM we have developed technology to enable us to have much more accurate flight heights through use of LiDAR technology, which is then flown alongside our standard stills cameras, and we're able to provide much more accurate flight heights for the birds that we encounter on those surveys. That then enables us to reduce precaution in those assessments, and that's fed back into the loop as well. As I say, it's really important to understand the difference between the characterisation studies that we do and dedicated monitoring or focused monitoring. This again is just one example where we looked at monitoring design at Greater Gabbard Wind Farm in the UK. The hypothesis was really to look at avoidance, particularly with regards to gannets. So looking at the hypothesis that the gannet densities would be lower adjacent to the wind farm than the background at sea density. So we looked at designing the survey for the statistical robustness, making sure the sample size was appropriate, looking at quasi-randomly selected transects to obtain the right number of records, and then doing the process of that in terms of looking at the numbers that were actually gathered through the digital aerial survey. So these lines are the transects that were flown with the aeroplane and the data gathered and assessed. So we were able to prove that the hypothesis was correct, that that's me over my time, looking at avoidance rates. So we are actually able to generate avoidance rates from that study, which have then been used back by the nature conservation bodies in terms of their recommendations on what avoidance rates to use within collision risk modelling, within the impact assessment. So it's really important that we do share that information. We look to reduce major consenting risks to developers by reducing precaution in our assessments. So just to finalise, summarise, in terms of recommendations, it really is about being aware of, when you're scoping your survey in the first place, what you can do, what you can combine. Think about the wider context and targeted objectives, whether you can actually combine the objectives of some of your studies, so whether you're looking at initial geophysical surveys and the use of that for benthic characterisation, to then look at targeting and doing on-site validations, looking at establishing limitations and understanding the variables, recognising that developers aren't able to carry out a lot of the research that still is required within the offshore environment. There are an awful lot of gaps there. But also recognising, that ecosystem models do need to look to kind of confront that uncertainty, and there are ways through collaboration that we can get more useful data sets for management decisions. Looking at future proofing as well, not being scared of actually looking at deviating from standards where there is evidence that that is improving it, and allowing some of that innovation to come through, looking at best available technologies, and actually also being aware of the changing policy and planning environment as well as we go through realms of environmental regulations. So yeah, importantly, plan and consult with your stakeholders, look at regularly reviewing the process of your data collection and check it against the original objective. And really, by doing that, you should hopefully manage the expectations both from the regulators and their advisors, and ultimately promote the results. There are additional benefits to just the projects themselves, and that can be useful to the wider environment and also help us in terms of delivering sustainable development goals. So yeah, hopefully you found that a useful oversight. Happy to chat about any of the content that I've got in there, or any specific examples and any of the technical aspects that we've covered. But thank you for listening.
Thank you, Julia. It was a really good presentation. Thank you so much for this. And now I'd like to go to our last speaker for today's session. But please remember that our speakers and the companies are happy to talk with you after the webinar. So don't hesitate to reach out to us and schedule calls with us. We'll be happy to discuss in more detail what we're doing in Scotland and UK. And I would like to go to our last speaker of today's session. And Charlie, over to you. I think we see your presentation, but I think we don't hear you.
Here we are now, I think.
Yes, now it's better. Thank you.
Good. Okay. Well, firstly, thank you for the opportunity to speak. Good morning, everyone. My name is Charlie White. I'm representing a company called W3G Marine. I'll take questions at the end. So what I'd like to do is give you an introduction to W3G Marine. Look at some of the projects that we have completed, and then focus on two technologies which are in development, one of them almost complete, the Hydronas and the FST, our pile stabilization tool, and then take questions, as I say at the end. So who are W3G Marine then? Well, we were formed in 2010, and the reason we set up was to develop and build a turbine installation vessel. Sadly, that never happened. However, along the way, we developed several technologies to support the ship. And these technologies, two of which we'll look at in this presentation, are at different stages of development. Our background is in offshore and subsea construction, engineering and management. So the kinds of experience we have within the company are project managers and owner's engineer. We have an R&D program developing technologies for any offshore application, whether it be oil and gas or renewables. We have a capability to oversee ship build and life extension of ship projects. We also manage offshore construction projects and mobilize equipment, and we design and mobilize back deck equipment. We're ISO 9001 and 14001 certified as well. Some example projects of what we've done in the past. This is a saturation dive vessel that was called the Harkand Haldane. It's now owned by Technip. We provided the project management team overseeing the excuse me, the ship build and the integration of the satellite, the saturation dive system into the vessel. Another example here, that there's the picture on the left there That is a kind of innovative concept design for a cable lay scheme. So we developed the scheme with our client, and we designed tooling for the scheme to work. The picture on the right, that's obviously real equipment. We did the structural design for the client. This gear here is to cut the legs of an offshore oil and gas platform that was being decommissioned. The picture you see here, it's a pipe lay system. It's called an HLS, a horizontal pipe lay system. We built this for DOF Subsea. This equipment has been mobilized many times in different configurations and with different adaptations. What you see here is called a false core. When cable or pipe is spooled into our, in this case, into a vessel, it needs some cable and pipe needs a certain bend radius. So this piece of equipment here in red, we designed and built that for Subsea 7. It can be containerized and therefore shipped worldwide to fit in with their operations and logistics. And to minimize vessel time, it can be installed in only six lifts. And the final example project that I'd like to share with you is the Kincardine Offshore floating wind farm. It is now the largest floating offshore wind farm in the world. We have been acting on the owner's behalf. The owners are a company called Kincardine Offshore Wind Limited, which is a subsidiary of the Spanish construction company Cobra. So our involvement in that has been as owner's engineer and project managers. And at the moment there are 5 9.5 Vestas turbines out producing electricity. The location of the wind farm, it's off the coast of Aberdeen. If you look in that bottom right picture, you can see in the box, that's where it's located. These are some of our customers over the years. I guess the usual suspects in there. Okay, if I move now to, I guess, the first technology that I'd like to present then, which deals with the issue of underwater noise. And in the context of offshore wind, really at the moment it's offshore piling that is the largest concern. You'll all be aware that when you kind of drive a pile, you make a large noise, and somehow in certain places of the world there are regulations to be met, and there are various different schemes on the market and in development to deal with this issue. Things like there's a scheme with tuned bubbles, plastic bubbles. There's bubble curtains, which we'll all be aware of, and there's another scheme which uses a concept of impedance mismatch, where they capture an air gap through the water column in 2 steel tubes. Now, the scheme we developed relies on exactly the same principle as that. However, rather than using heavy steel tubes, we use a material called drop stitch. Now, there's a picture of it in the bottom right of this of the screen. It's not a great picture. I have another drawing to show in the next slide. But in effect, it's 2 sheets of rubber that's internally constrained by many hundreds of thousands, millions of Kevlar strings. So, as I was saying, the picture on the top there, the drawing shows that there's 2 kind of plastic skin, and there's the drop stitch fabric in the middle. It can take a high pressure, even at depth. Now, the picture on the left is a test piece that we trialed in Dundee Harbour, and the three pictures, the deflated, half inflated, and fully inflated. When it's deflated, it is just like sheets of rubber, and it expands to whatever depth of air gap is required to meet the noise threshold. Let me go back a slide. I think I missed one there. I've gone one too far. So this is a trial that we did on the Kentish Flats. I think it was Van Oord, the vessel we were on. We deployed the Hydronas system overboard, and the picture on the left shows how it worked. We had a hydrophone inside the Hydronas, and we had one outside to pick up the noise unscreened. And we recorded 24 sets of 20 hammer blows. If I go back a slide, this was the results of that trial. I don't intend going through this, but we will be sharing the presentations with you, so you can interrogate and look at this afterwards. I mean, we see the system as high performing. I mean, the tests we did have demonstrated that, and we see the system having many other benefits, like minimal vessel downtime, because the deployment can be off the critical path, the use of minimal deck space or payload requirement. It's compact, it's lightweight, it's rubber with strings inside, thin strings. It can be air freighted, and it can be incorporated into a piling template or a gripper arm. And at the moment, I guess we're looking for opportunities to deploy this technology, particularly in the context of turbines, and therefore substructures and piles becoming larger and larger. So if I move now on to the second technology I'd like to speak about, called the foundation stabilization tool. Sometimes when a jacket is deployed offshore, it goes on to piles, pre-driven pin piles, and then there is a cement poured in which sets and holds the piles in the jacket firm. Now, that one of the issues has been the movement of the jacket from the ocean, and that has caused problems with the setting of the cement. There is actually a DNV standard on this now, where certain criteria have to be met when for grouting operations. There are several technologies on the market. All that I'm aware of use hydraulic rams, and in effect they push the jacket and pile apart from each other to hold it firm. All the subsurfaced, the sub-seabed equipment is generally lost. It's covered in cement and it's lost, which is quite expensive gear, could be down there. Our system, the W3G system, what we call the foundation stabilization tool, the FST, it uses low-cost components. It is sheets of steel in an innovative shape with different types of welding at different points. The technology, this is all we are doing. Final confirmatory testing at the moment. It should be fully certified within the next week or so, and it will be deployed on a European wind farm next year. I mean, the key components of the system, the picture on the left, this is the system fully inflated. There are pictures that follow that show it better than this drawing. In effect, you can see that the pile jacket are not centered. and the FST opens to the required gap to give the pressure and hold the jacket in place. So we have the gripper system at the bottom, where the jacket stabs into the pile. We have a scheme to inflate it, so there's a series of hydraulic hoses run up inside the leg, and it connects up to a remote inflation unit. This is a reusable package which can be operated remotely from the grouting vessel or installation vessel. This is a bit more technical detail. I won't go through all of this, but if anybody has any questions, I'm happy to answer them. You'll see in that top picture the red, the kind of pinky coloured, salmon pinky coloured parts to that. Those are the grippers, and the blue lines inflate, they pump water into the grippers and they expand to the required width to provide the stability. And some pictures to finish with. If I start with a picture on the right, this was deployed as a trial on East Anglia 1 a couple of years ago. As part of the development, you'll see there that it is starting to be filled with grout. Now the scheme on the left, this is in our facility in Aberdeen. You'll notice it's screened in a separate sheet of metal. We call that a pocket, and that's to control axial movement to stop the pile jacket slipping up and down. As I say, this product is weeks away from being certified, and is when we're finished that, we're looking for opportunities to use that on projects that require it. Not all do, but some jacket installations do. So thank you for that. I'll take any questions if there are any.
Thank you, Charlie, for your interesting presentation. I can see no questions in the chat box, so thank you for today. Thank you for joining us. This was the last presentation. Before I close the meeting, I would like to encourage you to register for the webinar in October, the topic of which is operation and maintenance of the offshore wind farm. Also, myself and Michał will be available in person next week in Wrocław at the Energy Congress. So feel free to stop by and speak to us if you are there. And if there are no questions, I am about to close this meeting. Again, I would like to thank all the speakers and all the attendees for joining us this morning, and wish you a good day. Thank you.